Myself Dr. M Palve, Assistant Professor, Department of Physics, Sangamner College, Sangamner. Today we are going to discuss the one topic from classical mechanics, and that topic is motion of charged particle in constant electric field. And the first topic is particle moving parallel to the constant electric field. In this topic, we have to discuss that what is the effect of the electric field on moving charged particles. We all are aware about this. When any charged particles which is present inside the electric field, let me consider these are stationary charged particles. This is stationary charged particles, and this stationary charged particle create the electric field around itself. In this electric field, if we place another one charge, so this Q0 charge experience some electric force, and that electric force is nothing but Q into E. This is the electric force which is acting on the charged particle in electric field. So in this topic we have to discuss that if any charged particle, let me consider Q be the charged particle, and this charged particle is moving inside the electric field. So this is the direction of electric field. This is the direction of electric field, and this charged particle is moving along x-axis having the velocity is a Vx. So what is the effect of the electric field on these charged particles? So according to the Newton's second law, when we apply the force on any particles, this particle get accelerated. So what happened here, when this electric force acting on the charged particle, this charged particle get accelerated, its velocity get changes. So we have to discuss in this topic what is the trajectory of the charged particle which is moving in parallel electric field. Okay, so let me consider one charged particles. Let me consider one charged particle which is moving along the x-axis. This is a charged particle plus Q charged particle which is moving along the x-axis having the velocity is a Vx, and we are applying the electric field along the x-axis which is parallel to the moving charged particle. This is the electric field along the x-axis. So let me consider this is the x-axis, this is the y, and this is the z-axis. When these charged particles moving in the electric field, the electric force, the force which is acting on the charged particle, that force is the electric force, and that electric force is F is equal to plus Q charged particle plus Q and the electric field plus Q. The direction of the electric force is along the direction of the electric field. If the charged particle is a negative, the direction is opposite. Means if the charged particle is a minus Q, so direction of the electric force and the direction of the electric field is a opposite. Okay, so if we consider the magnitude, so that times we have to don't consider this direction or a vector. So F is equal to QE, and according to the Newton's second law, that is when the force acting on any body or object, so that force is equal to mass into acceleration. So same here, when the charged particle is moving in the electric field, the electric force acting on the charged particle, and this charged particle get accelerated. So we can put here the value of F is ma is equal to QE. This is the acceleration A which is along the x-axis, and we know that acceleration is nothing but the change in velocity. Here the velocity changes with respect to time. So when this charged particle enter inside the electric field, so initially the velocity of the charged particle is ux. Let me consider ux be the initial velocity. Ux be the initial velocity at t is equal to 0. Means before entering in the electric field, the velocity of that charge particle is a ux. But when this charge particle enter in the electric field, electric force acting on the charge particles, and this charge particle get accelerated. Its velocity get changes. So let me consider put the age is nothing but the change in velocity dvx by dt is very simple, and q, the direction of the electric field is along the x axis, therefore we have written here qx. So the acceleration is dvx by dt, and it is equal to qex upon m. So this amount of the acceleration takes place. We have to find out what is the velocity of that charged particle in the electric field. On integration, so we can write here one step, dvx is equal to qex upon m and multiply by dt. Okay, after this integration, we get the vx is equal to the integration of dt is a t qex upon m t plus c1 is a constant of integration. So c1 is a constant of integration. How to find the constant of integration? At t is equal to 0, what is the velocity? Initial velocity is a ux. So therefore initial vx is nothing but the ux. Initial velocity is a ux. So if we put the value of the vx in place of the vx ux, and t is equal to 0, this value is a 0, this value 0, this is ux. So c1 is equal to, we get the c1 is equal to ux. So we got the value of the c1 is a, that is constant of integration is the initial velocity ux. So finally the velocity of the charged particle in the electric field is qex upon m t plus ux. So this is the velocity of the charged particle which is moving in the electric field, but that electric field is parallel to the charged particles. What is the position? So next point we have to discuss the what is the position of the charged particle in the electric field at certain time t. So this is the velocity, this is the acceleration, ax is equal to qx upon m, this is the velocity. So next point is we have to find the position of the charged particle at certain time t. How to find it? So this equation, we have to write this equation, vx is equal to qex upon m t plus ux. So this is the velocity of the charged particle. Okay. So Vx, we know that the Vx is nothing but the change in position or change in displacement. So in place of Vx we can write dx by dt is equal to qex upon m t plus ux. We have to find the x, take the dt right hand side, dx is equal to qex upon m t dt plus ux dt. We have to find the x on integration. After integration, okay, on integration x is equal to integration of dx is a x. We can write here integration one step, we can write here qx upon m integration of t dt plus ux integration of dt. Okay, after the integration we get the position of the charged particle in the electric field is qex upon m t square by 2 plus ux, and integration of dt is a t plus constant of integration c2. Okay, C2 is a constant of integration. We have to find the constant of integration C2. How to find it? At t is equal to 0, again what is the initial position? At t is equal to 0, x is equal to 0, because when we start the motion of the charged particle from the origin, when the charged particle enter in the electric field, before entering the position is equal, x is equal to 0. So x is equal to 0, it means we can write C2 is equal to, if we put x is equal to 0, t is equal to 0, t is equal to 0, so finally C2 is equal to 0. When we put C2 is equal to 0, the finally we get the position of the charged particle, x is equal to QEX upon m t square by 2 plus ux t. We can rewrite this equation, x is equal to ux t plus QEX upon m t square by 2. This is the position of the charged particle in the electric field at different time. So t is variable, so we can find what is the position of the charged particle when the electric field is parallel to the moving charged particle. When we compare this equation with the equation of straight line, y is equal to mx plus c. When we compare this equation with the equation of straight line, so it is comparable. So we can write that, so this charged particle moving uniformly in straight line, because this is the equation of straight line. So therefore we can say that the trajectory of the charged particle in the constant electric field which is parallel to the charged particle is a straight line. Charged particle is moving uniformly in straight line in electric field which parallel to the moving charged particle, moving charge particle. Okay, got it? So in this way finally we can say that when the electric field is parallel to the charged particle, the moving charged particle is moving straight line. Okay, so in the next topic we have to discuss that if the electric field is perpendicular, when the charged particle is moving along the x-axis and electric field is perpendicular along the y-axis, what is the trajectory of the charged particles? In the first topic we have discussed that when the electric field is along the x-axis, charged particle is moving along the x-axis, so what is the trajectory of charged particle? The trajectory of the charged particle is straight line. Okay, thank you very much.